Welcome to the next section, section 6, in the Contact Manager project. In this section, we will finally create the contact class, and in that process, we will also then create a contact runner so that we can start working with the class. So get comfortable. This one will take a little while. So, first, we have to get our code ready. So if you completed the previous section and you scored a 10 out of 10 possible points writing your address class, then you should follow these steps to get ready to do the next part of the lesson. Go ahead and download contact.java. Click the download link here, and then as soon as that has been downloaded, in Eclipse, you're going to drag contact.java into your default package. Click OK, and you are basically ready to begin. Now, you will see that there's an error in contact.java. That's okay. It's supposed to be there. This time, I'm giving you some code to get started, and then we'll be adding to the code instead of writing it all from scratch. However, if for some reason you didn't complete the previous lesson, or you got less than the full points on your address class, then your best option is to import the project into Eclipse. You want to save your work, however, so what you're going to do is you're going to right-click on your project, go down to Refactor, and select Rename. And go ahead and put your last name and first initial in front of the project name. So mine says Braskin A, Contact Manager Project. Click OK. Now that maintains your Contact Manager project, but allows you to go ahead and import by downloading Part 1, Section 6. And then you'll have to go ahead and import that in Eclipse. You're going to go to File, Import, Existing Projects into Workspace, select Archive File, click Browse, then select the Contact Manager Project 1.6, click Open, and click Finish. And this will give you the Contact Manager with the address class written from the previous step. Again, notice the contact class has some errors in it because it's essentially the same as this version that is posted online. You have the same code base. You got an address class that was written for you, so you didn't need to write your own. Okay, so you can also use this code to go back and look and see what you might have done differently if you had problems getting the full points with your address class. Okay, so let's move on to the address, or to the contact class. So first thing that you'll notice is we have a couple of imports. We're importing the array list and list interface, or the list interface and the array list class. And then there's something new here. We're going to have a contact class that is going to maintain a list of addresses. Well, why would there be a list of addresses in the contact? And the answer is this. We're going to make a contact that has one name but can have multiple addresses, and one of those addresses will always be the primary address, but you can have additional addresses, and you can swap and change which address is your primary address. Now, there's something else that you haven't seen before, which is the comparable interface is being implemented by this class. Why are we doing that? Well, we're going to use this contact class for follow-up lessons on sorting and searching. And just as you could compare strings using the compare_to method, you can make your own object implement the comparable interface, which means that you will, in effect, have a compare_to method, which you can then use to sort or compare two contacts to determine which one comes first in a list. And so that will be part of the lesson today, how to write a compare_to method. It's important to keep in mind that for the Java AP subset, you need to be able to use compare to, but you don't have to be able to write your own compare to method. This is simply something we're doing to make it easier for searching and sorting when we do this on the next steps. Now this time I've given you the instance variables, private name, and we're going to call it the person. So what we're doing is we're setting up what we call a has a relationship. Has a relationship between contact and name. We have our contact has a name object called the person. In the previous lesson, if you went through and you did the randomizer lesson, we had a whole bunch of objects that all implemented the same interface and extended the other ones. And we talked a lot about the is a relationship. So for example, a coin is a randomizer. And then we had an abstract randomizer that is a randomizer, and then we changed the coin so that it extended the abstract class, making it is an abstract randomizer, and so on. This is different. This is a has a relationship. We're using a contact to store a name, and we've given the name of that variable the person. That represents the contact for this contact, or rather the name of this contact's person. Okay, then the next instance variable that we have is a list of address, and we're going to call it the addresses. Now this is very important. You must not change the names of these instance variables, because when we do the test suite, it's going to rely on these instance variables having these exact names. Okay, so next we're going to look at our default constructor that we're going to write. The default constructor will instantiate a new name object using the default constructor of the name class. So let's go ahead and do that. So we're going to say the person equals new name. We've just constructed a new person using the default constructor of the name class, and then instantiate a new array list of address. Well, how are we going to do that? We're going to say the addresses equals new array list contact. And then this is a constructor, so I'm going to have parentheses and a semicolon. Okay. Oh, I said contact. Of course, it's not an array list of contact. It's an array list of address. Okay, so I've got the addresses is in a new array list of address, and I've constructed an empty list. And then finally, I'm going to make a new address object that will be instantiated using the default constructor for the address class, and it'll be stored in addresses. So we're going to say, let's see, we're going to say, address and address equals new address. We're calling the default constructor, and then we're going to say the addresses dot add, and then we're going to add the address object that we just created. Now, there is a way to save one little step here. I can use something called anonymous instantiation to save myself a step. And the way that works is I simply replace this variable with the call to the address method. And now I've used anonymous, yes, I think I spelled it correctly, instantiation. Okay, so that takes care of our default constructor. Next, we're going to have an overloaded constructor that takes a person and, a name and an address. Now, this is very important. We're going to be given a name object. Well, are we sure that that name object isn't going to be null? Because if it is null, what do we want to do instead of using that object? Because we don't ever want our contact to have null values. So the first thing we're going to do is test to see if setPerson is null. And if it is, instead of using setPerson, we're going to say the person equals new name using the default constructor. If it's not null, however, then we're actually going to use setPerson. But this is where things get interesting as well. We don't want there to be any link between this setPerson object and our object. We want them to be different objects. So what we're going to do is we're going to construct a new name using the information stored in setPerson, which we're going to retrieve. So we're going to say string first name equals setPerson dot get first. And then we're going to say string last name equals setPerson dot get last. And then finally, we're going to say the person equals new name first name and last name. Now, could we have simply said the person equals setPerson? Well, surely we could have, but then the program that gave us setPerson would still have a reference to our object and might change the values in our contact. And notice that the code says we're going to copy the values. So we haven't taken setPerson and stored them in our list. We've done something very different. We've copied the values in setPerson into a new object and stored that information. There's a very important distinction there, and it has to do with data integrity. We're guaranteeing the integrity of the data. Okay, so now we want to do the same thing for address. But for address, we want to make sure that our address is a valid address again. So we're going to do the same thing. We're going to say if setAddress is null, then the address equals a new address object. Did I misspell? Oh, I'm sorry. We can't do that because we're not just making a new address. We're making an address that we're going to add to our list. So we need to make an address object. And then, of course, I have to say addresses dot it's the addresses dot add the address. Okay? So this time I did it without anonymous instantiation. I did it as two separate steps. Now what are we going to do if address is not null? Well, in this case, we could go ahead and do the same thing. We're going to create a string for the street equals set address dot get street, string city equals set address dot get city, string state equals set address dot get state, string zip equals set address dot get zip. And then finally, we're going to say, now this time we're going to use anonymous instantiation. So we're going to say the addresses dot add new address, and then we're going to list each of these variables: street, city, state, zip. Okay, so now I have, oh, but you know what? I messed up. I forgot to do one step. Before I can add something to this address list, I have to instantiate the list. And I don't think I did that. No, I did not. So let's do that. The addresses equals new array list address. So So again, I'm instantiating the list, and the list was declared up here in the instance variables as a list of address. Therefore, when I instantiate it, I need to instantiate it as a concrete class array list of address. Okay, so that takes care of my default constructor. So now I want to do my toString method. And my toString method says it returns the name in first last format with the primary address on the following 2 lines. So how am I going to do that? Well, this is a simple one-liner. We just say return the person dot toString, because we could rely on its toString method. Then we're going to add a new line character, and then we're going to call our getPrimary address method, which we haven't written yet, but we will be writing it. And the stub for it is already in, so we're good with that. Okay, so that takes care of toString. Now, at some point in the Contact Manager, we might want to change the person. So there's a setPerson method, and this is going to be essentially a reproduction of the same exact code that we used up here in the constructor. So in fact, we can just copy and we can paste it right down here into setPerson. SetPerson, if setPerson is null, oh, there is a difference though. If setPerson is null, what do we want to do? Well, we're going to make this a simple short circuit here. If setPerson is null, we're simply going to return having done nothing. Now, this is a very important idea here. Notice that this method doesn't have a return value. So if I say return, I'm ending the method before I do anything else. This short circuits the method and prevents these 3 lines of code from executing. These 3 lines of code, of course, just get the first name and last name, and then set the person to a new name by copying that information. Okay, finally, next we have the ability to get the contact's name, and this is just going to be returning the person using their toString method, which we know returns the first and last name. Next, we have get last name first. Well, this one too is very simple. We're just going to return the person dot get last name first. Okay. Now, get primary address, and this we start to get into an interesting design question. How do we keep track of the primary address? We could create an instance variable that would maintain an index that would tell us which address in the list is the primary address, and that is a fully workable solution. I chose to go another way because it'll give us more practice moving things around in an array list. And so what we're going to do is we're going to say the first address in the list is always the primary address. Well, if the first list is the primary address, then this method becomes very simple. All we have to do is say the address, which we'll call our primary address, is equal to our addresses, and then we're going to get the address that's stored at index 0. And then we're going to take that and we're going to convert it into a string. Oh, I'm sorry. No, we're just going to get it. My bad. And then we're going to return the primary address as a string. Sorry for the confusion there. Okay, so we're going to basically retrieve the address at position 0 from the list of addresses, and then we're going to return it, but in string form. Now, why aren't we returning a reference to an address object and allowing the program to actually make use of the address object? And once again, the answer is we're trying to act as an intermediary between the address object and the rest of the program that's going to use our contact object. Once again, this is a design decision. It's a way of programming that could be deemed good or bad depending upon what kind of future we see for our objects. Do we want to allow people access to them, or do we want to really control and limit access to them? All right, well, we're almost done here. Now we're at our compare to method. So we've never written a compare to method before, but it's a good example of how we implement an interface that has only one method in it, and that's the compare to method. We've used compare to compare two strings. In this case, we want to be able to compare two objects, both of which are contacts. So let's take a brief look back at the start of our program, our class rather, and notice that it says comparable, and then we have our angle brackets again here, and inside the angle brackets we're comparing a contact. So we've implemented the comparable contact instance method. You can use generics when writing a implementation as well, and this is an example of how that's done. So now we're going to compare two contacts. Well, how do we compare two contacts? We're going to have, oops, this has got a little typo there. This should be other address. Oh, wait a minute. I'm sorry. I'm looking at the wrong one. Okay, so we're going to have another contact that we're comparing to, and we're going to return, remember the compare to method returns a negative integer, 0, or a positive integer, as this object is less than, equal to, or greater than the specified object. Well, how do we decide what makes an object greater than, less than, or equal to? And in this case, we want to sort our contacts in alphabetical order by last name. So the code is actually quite simple for this. What we want to do is we want to retrieve the last name of both objects that we're comparing, and then we can use a string compare to get the result. So first we're going to say string my last first is equal to the person dot get last name first, and then we're going to say string other last first equals other contact dot get last name first. And now if I compare the two last name first formats, I can simply say that whatever order they fall in is the order that I should return from my method. So I'm going to say return my last first dot compare to, and this is really important. Notice when I call the compare to method here that it compares two strings lexicographically, which is just another term for alphabetically. And notice it's compare string another string. Well, that's what we're doing. We're comparing two strings. So I'm going to select that, and I'm going to compare it to my other last first and return the result. And that's all it takes to write your own compare to method. It's actually quite simple. Okay, now at this point we're going to switch over and start creating our contact runner. When you're done with that, you're going to switch back and you're going to complete each of these remaining methods in this class. And when you're done with that, there will be a test suite for you to run. So at this time, we're going to go ahead and go back here, and we're going to go ahead and create a new class, which we're going to call Contact Runner. And we want our new contact runner to have a public static void main. So we're going to go ahead and check that box and then click Finish. All right. So what is going to be in our contact runner? Well, we're simply going to go ahead and put in a series of calls that will test the limited functionality of our contact class. So let's get started. We're going to delete this excess code here. All right, so where do we want to start? Well, we're going to start by simply instantiating a new contact. So we're going to say contact first contact equals new contact. All right, So basically, we've just instantiated a new contact using the default constructor. Okay, so that's great. Now, of course, we're going to want to see what it does. So, or what it looks like. So we're just going to do a syso system.out.println first contact, and then we'll go ahead and we'll restore that, run the program. Sorry, we had a little glitch there. We're back here. We're going to run the program, and all you see is a comma appear because my contact was completely blank. Well, that's not much fun. The default constructor for a contact doesn't do me a whole lot of good. So let's go ahead and let's modify that so that instead we go ahead using and let's fill it in. And we're going to fill it in by first creating a name object. So name, my name equals new name object. And we're going to call it, give it, you can use any name you like here. Okay. Then we're also going to need an address object. So we're going to say address, my address equals new address. And we'll go ahead and use not my address, followed by the city, followed by the state, followed by the zip code. Okay, and this time, when we create the contact, we're going to give it my name and my address. And then we're going to go ahead and output the result. Let's put a label on that. So, first contact, so we can see what it is. There we go. You can see we've got a full contact output to the console. So what do we want to do next? Well, let's see. What if we wanted to change the address? So I wanted to change the address that's associated with my contact. So as you will see, we haven't actually written the methods yet to let us go ahead and change the address because there's no direct way to just alter an address. What we would have to do is we have to add an address, make it the primary address, and then remove the other address, which is a lot of work, but we set it up that way. Again, I set it up that way to give you practice working with array lists. So what methods have we written that we could go ahead and use? Well, we used, let's see, we have a method that will go ahead and give us our name. So we'll say we're going to do a system out println, just the name. So we're going to say first system.out.println again. Okay, and then we go ahead and run that. You know what? Let's put a new line in there. Give us some space. It's easier to read. There we go, just the name. And then we can do the same thing to get some additional information if we wanted just the name in last first format. Well, then we would change this to be dot get last first. There we go. We can see Braskin, comma Aaron. Okay, so what other methods did we write? Well, let's look back here. So far, we've tested the default constructor. We've tested the get name. We've tested, we haven't really tested set person. So let's go ahead and change the name once we've made the contact. So here we're going to do first contact, and then in between we're going to go ahead and do a system out println, and we're going to change the name before we print it again. So we're going to say name, new name equals new name object, and then we'll have somebody else's name. And then we're going to say first contact dot set person new name, and then let's see the result. So we change the name, and then just the name, Ken Brennan, Brennan Ken, but originally it was Aaron Braskin. So we know that method works. Okay, let's go back. So that was our, we've done toString as well, by the way, since we've been printing the contact. So now we've got set person, we've done get name, we've done get last name, first name. How about getting the primary address? Let's see if we could do that. And the primary address, of course, should just be the only address we have. So let's do a system out, say, \n. The primary address is, and my contact dot, no, I'm sorry, it's first contact dot get primary address. And there we go. The primary address is, and it's the address that we gave. That's great. So now we're going to move on. Okay, what's the last method we want to test? We want to test our compare to method. How are we going to test our compare to method? Well, we're going to need to have more than one contact. So we're going to create a second contact. So we'll say contact second contact equals new. Now I'm going to give myself some space here. We're going to use anonymous instantiation to do a lot of work in one line. So we're going to make a new contact that's made up of a new name object. And then we'll make that name, let's see, what do we want to make the name? How about Jenna Brennan? And then the address, we'll go ahead and use a different made-up address, using, again, anonymous instantiation to make a new address object that has I'm going to shorten the name so it fits, and 90266. Let me get a real zip code. Let's see, what did I forget? That's street, city. Oh, I forgot the state. There we go. All in one line. We've made a contact in one line of code using two anonymous instantiations. Okay? All right, so now what I want to do is find out which of these two comes first alphabetically. So I'm going to say int order equals my first contact dot compare to second contact. Now remember, order will be less than 0, 0, or greater than 0, and it's going to determine that based on the last names, which are, in this case, the same, so then it should default all the way down to the first name. So you can put any names you want in here, and you should alter the names to see different outcomes. So let's go ahead and try it. So we're going to do now, I'm going to say if order is less than 0, in that case, that means that the first name was first. So we're going to do, we're going to do syso first contact, followed by system.out.println second contact. So let's see. Let's do this. Let's add a label here. We'll say syso. Okay. Contacts in alphabetical lexicographic order. Okay. has the S there. Now, else if order is greater than 0, then we're going to flip them. Second contact comes first. First contact comes second in alphabetical order. And then finally, else will print a message. So the contacts are the same. All right, so let's run our code and see what we get. We got Jenna Brennan first, Ken Brennan second. Now, if we change these names a little bit, so for example, if we change the name here so that it is, let's change this back to be Aaron Braskin. So I'm just going to comment out these 3 lines where I changed the name, and then run the code again. And notice Aaron Braskin comes first because it ran this bit. Oh no, first contact, I was first, so it ran this bit of code that time. Okay? Now, what would happen if we actually did this? We said second contact equals first contact. The contacts are the same. The code works. All right, so now it's time to go back to the contact class and finish writing the remaining methods. For each method, there's an indicator where your code starts, and then there's suggested steps for a way that you could complete the steps. Make sure that you read the Java.doc comment first because it explains what that method is supposed to do and how it's supposed to do it. Get to work.